Okay, so today we're going to talk about solving quick equations that involve logarithms, whereas yesterday we solved equations using exponential expressions. So the first type of solving a logarithmic equation is when you have a log expression on both sides of the equal sign. So we're going to pause the video here for you to write down number one. So because there is the same base on both sides, we can set what we're taking the log of equal to each other. Those are called the arguments. So we can set 2x plus 3 equal to 5x minus 6, and then solve for x. So let's subtract 2x. We're going to add the 6 to the left, so we get 9 equals 3x. Divide both sides by 3. And our answer is 3. Now you should check your answers when there's a logarithm, because for logs we have a restricted domain. So we have to go back up to the original. If we take 3 and plug it back in for x, we need to make sure that the argument, which is this piece again, is more than 0. So if we plug in 3 here, we're going to get a positive number, because it's going to be 6 plus 3. If we plug in 3 here, we're going to get 15 minus 6, so that works. 3 is our answer. Okay, so then the second type is when we only have one log expression. Oops, I'm sorry about that. So we're going to start with this one. And when you only have one logarithmic expression, here are your 3 steps. So we're going to pause the video so you can write down the 3 steps and write down this problem so we can solve it together. Okay, so the first step is to isolate the log. We have to divide both sides by 4. Okay, so now my log term is isolated, so we're going to change it to exponential form. We get 3 to the 5th equals 3x. We're not going to actually multiply this out because I noticed the base is the same here. So what we're going to do is we're going to divide both sides by 3 to solve for the x. It's our last step. So now we can use some laws of exponents to help us. 3 to the 5th divided by 3 to the 1st is going to be 3 to the 4th. Because we can subtract these exponents since my bases are the same. And 3 to the 4th, that's 81. If we plug 81 back in here for x, will 3 times 81 be positive? Yes, it will. So that means 81 is our answer. Okay, so we're going to try a few more of these. I'm going to move the steps down so we can keep looking at them. Okay, so let's try number 3. Log base 8 of x minus 5 equals 2/3. We're going to do this one together too. The first part, isolate the log. This expression is by itself, so now we're going to go to change to exponential form. We get 8 to the 2/3 equals x minus 5. Let's simplify 8 to the 2/3. I can split up that exponent to 1/3 times 2. So now 8 to the 1/3. What times itself 3 times is 8? This is going to be a 2, and then 2 squared is 4. So we're going to add 5. And we get 9 equals x. When you plug 9 in here, will this be positive? 9 minus 5? Yes, so 9 is our answer. Okay, we're going to pause the video here. I want you to try 4 and 5, and then we'll resume and check your work, and then we'll pause it again for you to do 6, 7, and 8. Okay, so for number 4, we need to isolate the log expression. So I'm going to divide both sides by 3. 6 divided by 3 is 2. Now that the log is isolated, we're going to convert to exponential. 5 squared equals x plus 2. 5 squared, that's 25. Our last step, subtract 2. So our answer is 23. X equals 23. That will work. This will be positive. That's okay. Okay, well, number 5. To start, we have to divide by 4 to eliminate the coefficient. Okay, my log is isolated. I have to convert to exponential. Remember, this is a base of e. So we have e to the 5/4 equals 2x. So then the last step, we're going to divide by 2. This is our exact answer here. You could also write it as 1/2 e to the 5/4. That's fine. For your homework, which is in your packet, I think it's, let's look at the top. (8.6b) odds. Okay, so on the worksheet 8.6b, to get your final answer and to check your answers with the answers in the back of the flip chart, you're going to have to type this into your calculator because all the answers on the answer key are in decimal form. So you can type this answer in and find the decimal equivalent, or you can type it in as we have here, and for your homework to be able to check your answers. Okay, we're going to pause the video again for you to try 6, 7, and 8. Okay, so for 6, the first step is to add 5. And bring this term down. Our log is still not isolated. We have to divide both sides by 2. Okay, so now that our log term is isolated, we can change it to exponential form. E to the 5th equals 3x. We're going to divide by 3. So our final answer is either e to the 5th over 3, or you can write that as 1/3 e to the 5th. Both forms are correct. Now for 7, this one should have been very quick. Because both sides have a log of base 10, we can set the arguments equal to each other. And now let's solve for x. I'm going to add 3x. I'm going to add the 9. Divide by 7. And 2 is your answer, but did you check it? If we plug in 2 to the right side, we're going to get 8 minus 9. Uh-oh, that's negative. That's log of -1. Is this possible? Can we have 10 to some power equal to -1? No. What about over here? Let's see. If we plug in the 2, we're also going to get log of -1. Even though both sides are equal, this expression and this expression they're impossible. You can't take the log of a negative number. So the actual answer to this problem is no solutions. And lastly, for number 8, we're going to subtract the 15. We're going to divide by 2. Convert to exponential. So let's see. 2 to the 8th is x. I don't have a calculator. I don't want to do this in my head. I'm going to leave it as 2 to the 8th as my answer. If I plug that in here, it's going to be a positive number. So our answer is whatever 2 to the 8th calculates to. Okay, so between yesterday and today, we've done 4 types of solving. So let's summarize. We have a little decision-making tree here. We're going to pause the video here for you to be able to copy this down, and then we're going to resume the video so that you can pay attention to me walking you through the chart. Okay, so either your problem to solve, so this is for solving, you're either going to start with an exponential expression or you're going to start with a log. So if you start with an exponential, you need to think, do you have variables on both in the exponents on both sides? If you do, this is the, like when we started a problem like this, for example, get a common base, set your exponents equal, and solve. If you only have one exponential expression, something like this, only one exponential, you're going to isolate the exponential expression, rewrite it as a log, and isolate x to solve. Okay, but if you start with logs, that's what we did today. If you have a log on both sides of the equation that are the same, they have to be the same, you equate the arguments, equal, and solve for x. That was the first way we looked at today. The second way is when you only have one log expression, you have to isolate the log, rewrite as an exponential, and then isolate x to solve. Okay, like I said earlier, for your homework, you can use your calculator to find the final answer. I'm going to turn the page to, these are the answers to your homework. They are on Edline. This whole flip chart will be on Edline. We can pause the video here and leave this up so that as you do your homework for the remainder of class, then you can check your answers.